Do students without a major and without support fall behind academically? Some students arrive at college with a clear academic path, others start undecided, and along the way, some seek help, like attending supplemental instruction or SI sessions, while others don't. But how do these choices and circumstances shape performance? Let's explore how major status and SI attendance affect first-year GPA and whether they work together in this Factorial ANOVA. In this study, we are asking, does GPA depend on whether a student began college undecided and whether they attended SI sessions? And is there an interaction between those two factors? Do undecided students benefit more from SI? Or is its impact consistent regardless of major status? This is a textbook case for a factorial analysis of variance. We have two categorical independent variables, whether the student was undecided in their major and whether they attended SI sessions, and one continuous outcome variable, first-year GPA. This model lets us test the main effect of each factor as well as the interaction effect, whether supplemental instruction works differently for undecided versus declared students. Let's walk through why we're using a two-way ANOVA, also called Factorial ANOVA. Our dependent variable is continuous. First-year GPA. We have two independent variables, each categorical. Whether a student is an undecided major, yes or no. Supplemental instruction, yes or no. We want to test for the main effect of each variable and the interaction effect between the two. That's exactly what a factorial analysis of variance is designed for. And if you're thinking about using this test in a formal research project, here's a full walkthrough of the study design you'd want to document. Start with your research question and hypotheses. Then we want to define your variables clearly. What's the outcome, what's the grouping variable, and how are they coded? From here, describe your data preparation steps, including how you filtered, recoded, and structured the data. Next, we want to explain the method you're using. We should also mention any assumptions you checked. And finally, report and interpret your test results, ideally with the comparison, test statistic, p-value, and what it means in context. This structure turns a simple test into a publishable mini-study. Factorial ANOVA gives us the main effect of undecided major, which answers the question, do students without a declared major earn lower GPAs? And the main effect of SI attendance, which answers the question, do students who attend SI sessions perform better? As well as the interaction effect, which answers the question, does the benefit of SI depend on whether the student was undecided? For each effect, we get an F statistic, a p-value. If p is less than 0.05, we treat it as a statistically significant result. Here's how to run a Factorial ANOVA in SPSS. Go to Analyze, General Linear Model, and then the univariate option. Then set GPA as the dependent variable. Move undecided major as well as attended SI into fixed factors. Go to Options. Check Descriptive Statistics, Estimates of Effect Size, and Homogeneity Tests. Go to Post Hoc, click on both of these, and drag them over into Post Hoc and select Tukey. It won't run these, but I want to show you why anyway. Click OK. SPSS is then going to give you a table with F values and P values for each main effect, and the interaction as well as the estimated marginal means. It also offers optional plots to visualize how the variables work together. If the interaction is significant, we know the effect of one factor depends on the other. Note first at the top, post hoc tests were not performed, and the reason is we only have two categories per each. So there's no point in exploring the differences at each level, as the difference is observed in the default. We see the distribution of students in each group here, showing the counts in each. Then we have a set of descriptive statistics based to each group, conditioned on the other group. So we see among those with the chosen major, those not using supplemental instruction have a mean GPA of 2.56. Yet among those with a chosen major who are using supplemental instruction, we see a mean GPA of 3.01. Clearly this is different, almost a half point higher, which if I were a college student would much rather a 3.0 over a 2.6. We then see those undecided, opting not to use SI, have a 2.2 GPA, and those undecided that are in fact using supplemental instruction have a 2.86 main GPA. Again, another difference. But is the interaction of these statistically significant? And are the interactions of these statistically significant, or is it merely a factor within their category? The next table looks at our quality of error variances. I will come back to this. Now let's look at our analysis of variance test. After running the analysis, here's what we found. Students who entered undecided had significantly lower GPAs than those who declared a major. This is evident by the statistically significant marker here. Then we see that students who attended SI sessions had significantly higher GPAs per the p-value here. But there was no significant interaction per the p-value that is not below 0.05, meaning SI helped both undecided and declared students similarly. So while both factors matter, SI is a universal boost, not just for those without a declared major. Now let's check the Levene's test, which we find has a p-value below 0.05, so we cannot conclude GPA variances are not equal across groups. This is an important note to make, as the recommendation is to suggest that the p-values for our effects, both the main effects and interaction, may not be trustworthy. But if I were to write this up for a study, I would note that, although homogeneity of variance were violated, given the large sample size and relatively balanced groups, we proceeded with the Factorial ANOVA, noting that p-values should be interpreted with some caution. And that's how we use factorial analysis of variance to see how student characteristics and supports impact academic outcomes. In this case, we found that, declaring a major and attending I both contribute to stronger GPAs, but their effects are independent. We do not see an interaction. Next up, we add ACT math score as a covariate to adjust for academic readiness using analysis of covariance. Subscribe and stay curious.